Hi, everyone. My name is Nigel Douglas. I'm hosting today's session, but I'm happy to introduce Paweł. He's going to speak about passwordless security. I'm going to add that to the stage now so everyone can see what he's presenting. And with that, I'm going to let Paweł take over, take the stage.
Thank you, Nigel. So, hi everyone. Thanks for tuning in to Security and Architecture track on CyberWise Europe. I'm Paweł, and I'm here today to share with you my vision of internet without using passwords. Before I start, a few words about me. I live in Poland, just 200 kilometers from Vilnius. I have been in IT for about 15 or 16 years. On my daily basis, I'm a developer and I work on web application, mostly using C# and .NET Stack. You may wonder why developer talk about security. It's about, I believe that every developer on his daily work should have security in mind. I have seen a lot of grim situation, a lot of terrible code, a lot of unsecure code, and I'm sure that we can do something about it. We cannot leave security only to security engineers. So, but let's go back to this topic, to main topic of this talk. Start with what is problem with password? Because we are using passwords for many years and they work reasonably well. So what's wrong? And well, there are plenty of issues. First, it's how to create strong password. How many characters should have a strong password? 8? Maybe 10? Is 20 enough, or maybe go to 30? Should we use all the possible characters, so uppercase, lowercase, digits, special characters, or maybe with a long password we can use only letters? What about long password made only with letters? For instance, long phrases, part of book, or lyric of a song. If it's a secure password or not. And what about non-Latin characters? Because in many countries we have some country-specific signs. Can we use them in password or not? Well, I haven't found one good rule how security password should look like. And another problem is need to create unique password. At first, it might seem like a nuisance, but over time, it begins more and more of a pain. And that's why most of us don't do that. There are statistics from Chrome Password Manager, which says that average user of this manager use same most popular password on 20% of pages. So 20% of pages or of accounts of this person is secure on with the same password. If this password leak, all those pages become vulnerable. And what's more, other pages are also secured with non-unique password. And this is why most people use really simple password. And in this word cloud, you can see password that appeared in collections made public in 2021. Those collections were from English-based websites. So as you see, the most common password are really simple. You have 123456, 12345678, or even 9. You had password, you have a QWERTY, and those a bit less common password are also simple. Those are mostly name, name of people, name associated to pets, dictionary phrases, brands, pop culture reference, and if you see something that looks like a complicated password, it's usually a phrase that it's easy to write on your keyboard. Like for instance, QWERTY. This is just a first row on your keyboard. And if we create a strong password and by some miracle we remember it, then unfortunately we are expected to change this password frequently. If this is not our, as users, initiative, we are forced to do it. And wise people say that we should not require frequent change password from our users. This is what Microsoft say. This is what OWASP say. This is what American National Standard for National Institute for Standard and Technology. All those well-known companies and organizations says that you should not enforce frequent change password from your users. While idea is good, then it ends up really bad. Because if you force user to change password every 30 or every 90 days, users start to create easy password. Or they simply add one on the end of the password and then during every change simply increment it. Or if your users are a bit more concerned about security, they will not add only a number, or they will add a name of season or number of year. And well, it doesn't make your password more secure, because if this password leaked, then the criminals will see this number at the age or name of season and understand that you need to only to increment it a few times and find a valid password. And even as developers do not follow this rule to change password frequently, because I know a lot of people who keep adding just one to their password. And some of them even brag that they work so long in one company that they have 45 or 90 something at the end of their password. But before I go further, one remark. We can force user to change password under some cases, and for instance, when there are evidence or suspicion that password may be compromised, then it's okay to force user to change password. But in many cases, usually we should keep them with their password. Another problem is how to manage those passwords, because remembering things is hard. You probably know a lot of people who have their PIN code written on a credit card. And the PIN code is only 4 digits, and password is longer. There are a lot of passwords. So those passwords end up on post-it notes, which are glued to table on the wall, to your screen, or under your keyboard. And it's hard to find good stats. How many passwords have average person? So I take a look on my accounts, and it appears that today I have 193 accounts for personal use and 44 accounts for my professional business use. So totally more than 200 passwords. And by no means I'm able to remember it. I think I remember maybe 10 or 15 passwords, but I use, for most passwords, the only solution is to use Password Manager. And Password Manager are fine. If you use product that is well known, which was product that is checked by other developers and organization, if you don't use some really unique brand new approach, then Password Manager should be fine. But still, password managers are far from perfect. Why? Because Password Manager is another system. You have a desktop application, you have a mobile application, you have some cloud account, you have a mechanism to synchronize those passwords between your devices, and you also have a browser extension which will integrate with your browser and to make it all easy to use. And as you see, there's a lot of places when something can go wrong and eventually will go wrong. For instance, 2 years ago, LastPass was hacked. I'm not sure if password leaked. I'm sure that they were encrypted, but some of nodes or private data stored in this password manager could be exposed. And it's not the only case with LastPass, because a few years ago, this is a link to article from 2017, the portal Hacker News examined 9 popular managers and found vulnerabilities in every single mentioned password manager. Of course, exploiting that vulnerabilities was sometimes really challenging. It's not just making a simply HTTP request or fiddling with HTTP headers. But eventually, all password manager is vulnerable to some degree. And unfortunately, even if we create secure, strong, unique password and remember it, it still might be not safe. And this is not our fault as users, because password keep leaking from services we use. And this is mostly due to developer carelessness, because some developers still use MD5 algorithm to hash passwords. Some still use SHA-1 algorithm. A lot of systems I work with didn't use SALT to secure the password. In many cases, during creating new account, user were given default password and user were not forced to change those passwords, so those default password can be used for many years. And what is more, maybe not funny, what is more scary, this default password were kept for all users and were also written in manual. So you just can, if you want to attack some other account, you just need to know email, because with a lot of chance, this user will still use his default password. And also, a lot of service at the websites store their passwords in plain text. A few years ago, I made an audit on an application when all passwords were kept in plain text. I reported that problem, and this is the response I got from chief architect. Blah, 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 there is no need to encrypt user password because database and server are secure. I leave it without a comment, because what much I can say. And even if we store password in a hashed manner, are we sure that passwords are not leaking on any side channel? For instance, Facebook a few years ago had an issue when passwords were stored in logs. Of course, in plain text, because passwords were part of HTTP request. And there were not a lot of passwords. When thinking about the scale of Facebook, there are about 10 or 20,000 of password. But still, how many of developers are sure that this password are not leaking through logs, through some analytics, or maybe through backups? I think not many of them can be sure. And this is why password leak out. But it not really leak out like those in picture. Those leaks look more like this. Those are massive leaks of 100,000 of even million of passwords. ForgeRock, this is a company which work in identity and access management, estimated that in 2021, a bit less than 2 billion of passwords were exposed. 2 billion of password in just 1 year. And I think we can trust them. Probably many of you know this website, Have I Been Pwned, when we can check if our credential was exposed. And this is screen from yesterday. As we see, this website contain more than 13 billion of credentials for accounts. 13 billions is roughly 2 credentials for every single human being on Earth. So it's quite a lot. And I also was affected by one of the leaks, because my credentials were exposed from a Dropbox account, and what can I do about it? Pretty much nothing. It was good that I had unique passwords, so this didn't make a lot of impact for me. But many users still have this password which are used on many websites. And of course, there are a lot of other problems, like for instance, phishing. And phishing, now it's, I think it's number one security problem. Most of reports about attacks say that attacks start from phishing, even those more complicated ones. First, attackers send email or write a message on some kind of communicator, then get access to the system, and only then use those fancy, complicated techniques to escalate their privileges. Verizon said that in 2019, 1 in every 99 emails was a phishing attempt. I'm not sure if this is valid because I think it was more than one, but maybe 80 from those 99 was a simple spam. Deloitte says that 91% of data breaches happened because of phishing. Symantec also says that most of targeted attack start with spear phishing. So spear phishing is a phishing but aimed for a specific group of users. And even if we look at smaller scale, this is data from Poland, where I live. CERT Poland is the most important civilian emergency response team in Poland. And they publish the reports every year. And in the last report, they say that in 2023, more than 51% of all unique incidents were phishing. And those 51%, when we count them in, this was 41,000 of incident, 41,000 of phishing attempts. And what is more frightening, those 41,000 comparing to previous year means that there was a rise of 61%. So, and if we look at even more old reports, we see that the number of phishing attempts of phishing attacks still is growing. And some of you may say that phishing is not a problem because we already covered it. We have two-factor authentication, and this solves this problem. And well, that's not true. I will show you an example. Here you see the flow using second factor authentication. We have our user, we have our server. User asks server to create a one-time password and send it using side channel, for instance, mobile application, and then the user sent both password and this one-time password to the server. Looks fine. But if some malicious actor work on live during our session, he can simply do kind man-of-the-middle attack and simply ask our user to send this one-time password to this criminal, and then criminals use this password and one-time password to the cloud. It is a bit more difficult flow, but it's still possible, and it's really common during attack, for instance, for bank or for bank accounts or e-commerce platform. And there are also other ideas how to exploit those two-factor authentication. For instance, there is something called MFA bombing attack. If you set a lot of authentication requests to user, at some point the user will become annoyed because his mobile phone will be ringing for all the time, and eventually user will accept those requests. This kind of attack happened, for instance, it was done by Lapsus group, and in which attack this group sent a lot of authentication requests for one of the Uber employees, and then called this employee and say, hey, we have some problem, just accept one of those requests and everything will be fine. So Uber employee accepted request and criminals have access to Uber infrastructure. Of course, there is one more solution which may secure us before phishing. And I'm talking about security keys, security hardware keys, but they have their own problems. Security keys are expensive. You need to pay at least 25 euros for YubiKey, and you need 2 YubiKeys, so it's at least 2 YubiKeys, so 50 euros. And you won't convince your user to pay 50 euros for thing to improve their security. User believe that is our developer job to secure their accounts, and well, they're right. And even if you use YubiKeys, I'm not sure if you see that on the screen, but this is not a stock photo. This is my collection of YubiKeys. I ended up with 6 devices, and you need to remember when you put them. You need to remember to do backups. You need to not to confuse your YubiKeys with some other YubiKeys, and you need to care to not to damage them. Yes, it is possible. So there are a lot of other problems, and eventually we kept adding additional layers to password, but this mechanism is fundamentally broken. This is still analog mechanism that we keep using in our digital world. And if you think about yourself, because I presume if you are here, you are IT professional. Do you follow all good practices regarding password? Do you use password manager? Do you use second factor authentication, multi-factor authentication, or security key whenever possible? I think not, but I do not blame you. Security is hard, and from the perspective of ordinary user, is even harder. So what we can do about it, we as developers? Since passwords are not the best approach, what alternatives we have? You can authenticate yourself in 3 ways. By something you know, like password, by something you have, like security key, or by something you are, like biometrics. Or you can use combination of those 3 means. And we came to the point of this talk, to the mechanism called Passkeys. You probably heard about it. There were a lot of buzz about this idea last year. In this year, it's a bit less hot, because Passkeys are not a revolution. They are based on well-known technology, but the biggest difference is that they offer a much better user experience for end user that will use those passkeys. Ultimately, passkeys are just a customer-friendly implementation of FIDO2 standard and web authentication standard. It is I once heard that the initial name of Passkeys was Discoverable Web Authentication / FIDO credential, but the Apple company decided that, well, you won't be able to promote technology with such names, so they go with Passkeys. And how it works? You need 3 things. First, you need some device that can handle cryptography, that can store data and verify user. And this device don't have to be brand new, because all protocols like FIDO and CTAP were known for at least 5 or 6 years. So I bet you have already such device. You need fairly modern version of operation system, so it can be Chrome OS, it can be Mac OS, it can be Windows. It doesn't fit well with Linux, but you can still use it. I will talk about a bit later. And the third thing you need is up-to-date browser And this browser needs to be based on Firefox, on Chrome, or in Chrome or in Safari. It doesn't need to be exactly Chrome or Firefox, but every browser based on this should work quite fine. And when we look at those three requirements, I bet you already have a set of these things on your desk. How it look on detail? This is compatibility chart. This screen was taken yesterday. It is a bit misleading because Chrome OS and Windows are marked as planned, but they already support Passkeys, but not in every scenario. But you can still use this Passkeys on device with Chrome OS or Windows, even Windows 10, which I will show later on the demo. Only Linux users are a bit behind. You can still use Passkeys on your computer using Linux, but you need to another device with Mac OS on or Android on it. I will also cover this a bit later. Well, but how this all work together? Answer is simple. This is just an asymmetric cryptography, also known as the public key cryptography. I don't want to dig deep in this idea of cryptography. This is not a place for academic speech, so let's go to example. We will start with few workflows, and the first one will be registration new account or on some website. We have our device that we will use to authenticate. We will have our browser, and we will have some server. When we want to register your account, we'll send a request to server saying, hello, my name is Jane, I want to create a new account. Then web server creates some data, some storage for this account and create challenge. Challenge is just an array of bytes that we will need to process. And then server sends the browser name of domain, information about user, so his ID and challenge, and this challenge to sign. When we look at code, it looks like that. We have this challenge. This is just an array. We have information about server. RP is abbreviation of relying party. And this information about server is domain, which will be used to check credential. And there is also a name which will be displayed for user. We also have information about user, so we have this ID and we have some name that will be displayed and some other configuration things. This information was received from a browser and then it is sent to thing that will authenticate those accounts. This thing can be your mobile phone, so all this part is on your mobile phone, or this thing can be, for instance, YubiKey. So browser will run on a laptop and authentication will be done on YubiKey. So here your browser sent to authenticator all the data that was received from a server, and the browser also include the name of domain from your which was this name which was resolved by browser. You may ask, why do we need this domain name 2 times? And the answer is simple: to avoid phishing attacks. I will talk about it a bit later. So, authenticator will create your credentials with some ID, will create private key, and this private key will not leave this device. Will save additional information, that is domain name and information about user. And authenticator asks user to unlock the device. It's required for this authenticator to have some mean to check user. So for instance, in cell phone, you need to unlock your screen. In Windows, you need to use Windows Hello. If you use a security key, hardware key, then there will be a notification on screen of this of your computer to put your PIN. So you need to authenticate, not only verify your presence, not only to push a button, but also provide some verification that you are really you. It doesn't matter how this verification will look like. It can be PIN code, it can be biometrics, it can be camera, it can be some shape you need to draw on your phone, but there must be some way to authenticate our user. If this go okay, then authentication sent to our server credential ID to simply know how to access these credentials later, public key that was created, and just a signature of this challenge. So this signature is this challenge encrypted using this private key. Browser sends this data to the server, and server check if this signature can be decrypted using public key, and in result we got this challenge. If yes, then we create a user account, we'll store credential ID to later know how to access this user, restore public key. We remove challenge because challenge is not needed later. This is only used for one time for every authentication process. So we end up with state like this. We have our user data on server with credential ID and public key, and we have the same credential ID on the device, but here we have private key, and this private key will never leave device, and public key alone is not enough to perform our authentication. While this may look a bit complicated, let's go to demo. Sorry, not a demo, but for another process, how to log in. We start with the end state of previous case. So now user want to authenticate, send his username, for instance, then server create a challenge, send this challenge credential ID from here and domain name to the browser. Browser send this back and also added this domain name. This code in JavaScript would look like that. So again, we have our challenge, we have ID of our server, and some data about user and about setting of authentication. Now authenticator get those data, check if domain name fits, check if you know this credential ID. If yes, then ask user again to unlock the device. If device is unlocked, then this challenge is encrypted using private key, and only this signed challenge, so signature, was sent back to server, and server check if this challenge can be encrypted using public key. If yes, and if this encrypted challenge is equal to this challenge that was sent, then everything is fine and user is logged in. To prove that it works, I will show a demo. And this demo will be just a part of screen because, as you probably know, there are a lot demos tend to fail. So I'll always show screens. This is made using a website called Passkeys.org. You can go to this website and try this flow on your own. I want to create a new account, so I will write my login. Then I will choose option sign in with passkey, and then I got a notification from my phone if you want to create a new account. I will choose option to continue, then I need to unlock my phone again, and boom, everything is fine. I just created my new account. No thinking about password, everything was done on Backstage. If we want to create our account on a different device, when there we need to create another pair of keys. If we want to log in, again, I just go to web page, put my username, use sign in. Then I got notification, hey, do you want to use passkey? I unlock my phone, and boom, I'm already logged in. Everything worked almost seamlessly. You just need to unlock your phone, and I bet you do this 100 times a day. Where are those credentials stored? If you go to settings of your phone, this is screen from Android device, you see in your password manager, you can see that we have this credential for passkey.org website. If you go to the details, you can see the options edit and delete. I cannot do a screenshot of this option, but if you try to edit, you can just only edit metadata. So this data which is shown for user, you cannot change the details. You cannot your private key, and you're not able to retrieve this private key. This is what specification said. Users are not able to extract those credentials on their own. This procedure will look quite similar on your laptop. You probably just have this a bit different interface because it depends on your operational system. But what if you want to log in on your account, but using a different device without this key? Well, there are a few options. There is a thing called cross-device authentication. I went to the same page using Windows computer and Vivaldi browser, and I want to sign in. And I have two options. I can either use Windows Hello or security key, so things that can be connected with our computer by cable, or use additional device like phone or tablet or security key. If I choose security key, so YubiKey, I just got notification, hey, put inside your, connect your YubiKey and authenticate. So press this button and fill your PIN code. And again, you're logged in. But if you want to log in using your mobile phone, then the browser will show you this QR code. You need to take off your phone, scan this code, and this is how it looks on your cell phone. You see that there is some kind of weird URL. This is how it look when copy pasted from device, and what you can do without it. There are two options. You can copy it, which I'll do to show you this code, and you can open it in browser. When you open it in browser, you're asked to turn on your Bluetooth. Why use Bluetooth authentication? This is also security against phishing. This cross-device authentication works only if your computer and your mobile phone can connect via Bluetooth. So there is impossible to send you this QR code through internet and use this authentication from some remote phishing. Bluetooth make sure that both devices are in some proximity, just a few meters. If those devices can connect, then I'm asked if you really want to connect using this passkey, then you unlock your phone, and boom, I am now logged in on my PC. And what is most interesting, credential was not sent from those private key was not sent from my phone to my computer. My credentials are still on my phone. Only this signed signature was sent to my to my computer, so this signature cannot be sent to log in again. But remember that these computers store your session token or cookie, so you should not authenticate on devices that you're not sure if are safe, because your security may be exposed on a bit different layer. And this is how it is secure against phishing. And talking about phishing, there are a lot of things that can be done here, because what can an attacker do to phish your account? Those credentials are stored in device and cannot be read from device. Even if somehow this part, even if attacker have access to real server and create malicious server, for instance, not acme.com but aome.com, if the attacker know all the data from the real server, that still they cannot force us to do authentication, because our authenticator will see that real domain read by browser, and those fake domain sent by attacker do not match. So simply changing domain do not expose us to phishing. And what about using multiple devices? Because I show you an example of this cross-device authentication, but what if you have desktop computer, laptop, tablet, or mobile phone? Well, there are some solutions. If you use Apple or Google device, then your passkey is stored on your account, Google or Apple account, and it's secured inside this ecosystem. In theory, it could be shared between those ecosystems, but providers are not willing to make it easier. Okay, so it sounds a bit weird because my data need to be put on someone else's cloud, which sounds suspicious. If you are not really exposing your accounts to other companies, then you can use Password Manager, because at least those 8 password managers can work with Passkeys. But if you use Password Manager, then your passkeys are not stored in enclave or TPM, are stored in a bit less secure manner. And some of those password managers can be self-hosted. So in case of any problem, you own all the infrastructure. Okay, but there is another problem. As I mentioned before, the passwords are leaking, even from password managers. So there's a danger that your credential might leak, even from password manager. Then you can still use your YubiKeys or any other security device which support FIDO2 standard, but those you need to check if those devices work with this standard. And there's a small issue. YubiKeys can store only 22 passkey on device. So if I had more than 200 devices, then I need about 9 to 10 pair of YubiKeys, so about 20 YubiKeys. That's a lot, but everyone can find approach valid to their threat model. Let's go a bit faster. There are a lot of pages that support passkey right now. You see this pages passkey directory. Now there are 55 pages on this list. When I done this talk 1 month ago, there was 20 pages less. So this is growing. You see companies like Adobe, LinkedIn, NVIDIA, Sony, a lot of big names. What I saw as a developer, passkey are mostly described as a perfect solution when it's not so simple to implement, because specification has 165 pages. There are a lot of so-called sharp corners. You need
Hi,
to know.
Paweł. Sorry, I think we're short on time. We have seconds left.
Okay.
Is there anything you'd like to just quickly close out on, or people can still reach out to you directly?
Okay, so just two last sentences. Implementing password is harder than I thought. This is not just installing one packages, but it's still not much harder than correct implementing of passwords. So you need a person who know what he's doing and someone who is into security, but ultimately is not as hard as I thought that it will be. Last slide. I'm sure that many companies won't introduce Passkeys because how often do you change your authentication mechanism? But for now, I think there are no better solution that can be implemented for ordinary users. And if you have some question, you can always call me using my social media. As I see that we don't have any questions on the chat, or do we have?
No, I don't think we do.
No, so
the session was amazing. I'm going to have to close it out, but Paweł, for those attending, feel free to reach out to him directly, and I'm looking forward to hearing more about this in the future.
Okay, thank you, Nigel, and I wish you a great conference.
You too. Thank you, everyone, for attending. Bye for now.
Bye.